Hello everyone. Welcome to our lesson. Today we're going to be talking about conditional probability. You're going to be introduced to two more rules for probabilities. One of your learning objectives is to be able to calculate probabilities using conditional rule and the multiplication rule for probabilities. Also going to learn how to determine if two events are independent or dependent. Okay? That will be the focus of this lesson. Again, after this lesson, you're going to have a total of 4 rules. The addition rule, the complement rule, the conditional probability rule, and the multiplication rule. Let's get started with the conditional probability rule. There's going to be instances where one event has occurred, one event has happened, and that event is going to influence the occurrence of another event that follows after that. Okay? In other words, if an event happens, that event might affect the probability of another event happening after that. Conditional probabilities are calculated based on the condition that a specific event has occurred. If we're being told that event B has occurred, we do not need to consider the whole sample space. If an event has occurred, that is going to restrict the sample space. We're no longer going to be looking at all the outcomes that can occur with a specific random process. Okay? So just keep that in mind. You're going to see how that happens when we compute the probabilities. Okay? So let's go ahead and talk about computing probabilities using the conditional probability rule. The conditional probability of A given B has occurred is given as P of A given B. Here, when you look at that vertical line between A and B, that represents given. Okay. So again, we read this expression as P of A, so the probability of A given B has occurred. The conditional probability is computed as follows. The probability of A given B is equal to the probability of A and B divided by the probability of B. Notice here on the denominator, we have the probability of B. When we compute theoretical probabilities on the denominator, we have the number of events in the sample space, right? Now here with this probability, we have the probability of B on the denominator. This is a way of us restricting the sample space. We are no longer looking at the whole sample space because B has occurred. If we're computing the probability of A given B, we're going to use this formula. To use this formula, we're first going to need to find the probability of A and B. Then we're going to need to find the probability of B. Okay. Once we have those values, then we can simply take our answer for the probability of A and B divided by our answer for the probability of B. Okay. Let's go ahead and look at an exercise where you're being asked to compute a conditional probability. Okay. We're going to consider the experiment where you roll 2 dice. Okay. So that is really important. We're not just rolling 1, we're rolling 2 dice. What is the probability of getting a sum of 5 given that the first die is a 2? So here we should already be thinking this is a conditional probability. Let's use the conditional probability rule. The probability of A given B is equal to the probability of A and B divided by the probability of B. Now you might be wondering, what's A here? What is B? We get to decide that. We can say A is going to be the event of getting a sum of 5, and B can be the event of first die is a 2, or first rolling a 2. Okay? You could also do this the other way around. It doesn't matter. In order to use the conditional probability rule, we need to find the probability of A and B. We also need to find the probability of B. Let's start by finding the probability of A and B. To help you find probabilities, I am giving you the sample space here. I created a sample space here by thinking about the possibilities of the first roll and the possibilities of the second roll. So notice I started by saying, well, it could be the case that I get a 1 on the first roll, and if that happens, I could have a 1 and then a 1 on the second roll. I could have a 1 and then a 2 on the second roll, and so on. A 3 on the second roll, a 4, a 5, a 6 on the second roll. And then I said, okay, what if I get a 2 on the first roll? Okay, then I could get a 2 and then a 1 on the second row, a 2 and then a 2 on the second row, and so on. 3, 4, 5, 6. So that is how I came up with the sample space. You could come up with this sample space on your own following that thinking process. One thing that I want to take a note of is that we have a total of 36 outcomes in the sample space. I'm just going to write 36 outcomes in SS. Now let's ask ourselves, what is the probability of A and B? What is the probability of getting a sum of 5 and rolling a 2 first? Well, let's go ahead and look at that. Here, we have all the outcomes where we see that we got a 2 first. Okay. Notice here, we do want to roll a 2 first, but we also need a sum of 5. Notice there's only one outcome where we would roll a 2 first and get a sum of 5, and that would be if we roll a 2 and then we roll a 3. Okay. So the probability of A and B is 1. That is the number of ways we can get a sum of 5 and first roll a 2. So that is one outcome out of 36. We have 1 on the numerator. On the denominator, we need the number of outcomes in the sample space. We have a total of 36 outcomes in the sample space. Now, what about the probability of B? The probability of B is the probability of first die being a 2. Okay. Here in the numerator, we need the number of ways, the number of outcomes we can get a 2. Notice there's a total of 6 outcomes where we see that we roll a 2 first. So here we're going to have 6 different ways of rolling a 2. Now, on the denominator, we need the number of outcomes in the sample space. That is 36. With this, you can compute the conditional probability. Go ahead and use our formula. The probability of A and B is 1 divided by 36. The probability of B is 6 divided by 36. Go ahead and type this on your calculator. You should be getting 1 out of 6, which is equivalent to 0.1667. Look at what we did. We recognized that we had a conditional probability. We pulled out the formula for the conditional probability. And then we took this in steps. We said, let's find the probability of A and B. Then let's go ahead and find the probability of B. Once we have those two probabilities, we can go ahead and plug in those values into our formula. One thing that I want to emphasize here. Earlier I said you're going to be restricting the sample space. How did that happen? Notice what we have here. We have a 6 on the denominator. The fact that B happened, the fact that we first roll a 2, is affecting that denominator. The denominator, which is 6, ended up being the total number of outcomes where we see that a 2 was rolled first. Okay. So again, we're restricting the sample space with the event space of event B. Now here you have another example. In this example, you're being asked to consider the experiment where one card is drawn from a deck. We're talking about the deck of 52 cards. You're being asked, what is the probability of getting a diamond given that the card is a king? So here, notice the given part is that the card is a king. So here, RB is the event of the card being a king. Event A is the event of the card being a diamond. Okay. So I'm going to let you do this on your own. Notice we have the probability of A given that B has occurred. We see the word given here. We know we need to use the conditional probability. We go ahead and pull out the conditional probability rule, and then we ask ourselves, okay, let's first compute the probability of A and B. Then let's go ahead and compute the probability of B. Once you have those two probabilities, you're going to be able to take the probability of A and B divided by the probability of B. I'm going to let you do this on your own. I'm going to be asking you to provide the probability of A and B. Then I'm going to be asking you to provide the probability of B. And then finally, I'm going to ask you to provide your final answer for the probability of A given B.